Let's take the integral of the square root of 9 minus x squared divided by x squared. Now this might seem like a complicated integral, but if you recognize certain things, it will be easy to compute. So the first thing that I'm drawn to is that square root term. That square root term is in the form of a squared minus x squared. And this is a perfect contender for a trig substitution, in this case, sine substitution. If I say x, or if I would substitute sine by defining x as a sine theta. And this comes from the trigonometric identity 1 minus sine squared theta is equal to cosine squared theta. Because once I substitute the sine term in, I can reduce the integral, or the square root. So let's just plug that in. Let's just compute that substitution to our integral. I have the square root of 9 minus x squared. So in my case, x would be 3 sine theta, because my a squared term is equal to 9. Therefore, a is 3. And then I can get my dx term from this, which is 3 cosine theta d theta. And now I could just immediately substitute this into my integral. So I'll have square root of 9 minus x squared, where x is 3 sine theta, so this is 9 sine squared theta. And then I have an x squared in the denominator too, so that's 9 sine squared theta as well. And then of course I multiply by the dx term, which is 3 cosine theta d theta. And now I have to simplify things and clean it up basically. So the first thing that I can clean up is my square root term. So if I notice that this is exactly the trig identity up here, which is, but instead of 1 minus sine squared theta, I have the whole thing multiplied by 9. I can factor that 9 and even take it out of the square root, so I have 3 square root, and instead of 1 minus sine squared theta, I have cosine squared theta divided by 9 sine squared theta times 3 cosine theta d theta. And then this 3 multiplies with this 3 to create a 9, which then cancels out with the 9 in the denominator. And then if I look up here, I have the square root of cosine squared, which the squared and the square root get rid of each other. And so I end up with the integral of cosine squared theta over sine squared theta d theta. And then this is the integral of cotangent squared theta d theta. And now I just have to work out the integral of cotangent squared theta. And the way I'm going to do this is by utilizing another trig identity. And that one is that cotan squared theta is equal to cosecant squared theta minus 1. And the way I get this is by, if I go back to what I have over here, if I divide this whole thing, actually I'm going to write it down here, starting off with sine squared theta plus cosine squared theta is equal to 1, if I divide the whole thing by sine squared theta, on both sides of course, I will get that 1 plus cotangent squared theta is equal to cosecant squared theta. And that's how I get this definition over here. And so my integral now becomes cosecant squared theta minus 1 d theta. Now the integral of cosecant squared is just one that we know, and that is just negative cotangent theta. And then the integral of negative 1 is just negative theta with respect to theta. And because this is an indefinite integral, then I have to add a c term. But we're not done yet. Even though we're done integrating, we're not done yet because what we started with, the variable that we started with, does not match. So I have to go back and substitute everything back in. How do I do that? Well, let's go back to the definition. I defined x as 3 sine theta. And I'm going to write that down here. X is equal to 3 sine theta. So then sine theta is equal to x over 3. I can create a triangle out of this. So I'm going to draw my right triangle. And if I define this angle here as theta, my opposite, and obviously the definition of sine is opposite over adjacent, or sorry, that is tangent, opposite over the hypotenuse, I get that the opposite is this x over here, and the hypotenuse is 3, and then just Pythagorean rule, this is going to be 9 minus x squared, square root, of course, all under the square root. And so, also using the fact that cotangent theta is equal to 1 over tangent theta, where tangent theta obviously is the opposite over the adjacent. In this case, or in the cotangent case, that's just flipped, so it's just the adjacent over the opposite. I basically have everything I need. And also we could define, this is getting messy, we just define theta here by taking arc sine. So this becomes arc sine x over 3 is equal to theta. And now I have everything I need to just substitute it back in. So my integral is now equal to negative cotangent theta, which is just the square root of 9 minus x squared, all over the opposite, which is x, minus arc sine x over 3 plus c. And that's it.